In this second video, we're now going to move on to solving problems using the central limit theorem for the mean. Remember in the activity from lesson 5-1, we talked about rolling dice. And when we rolled dice, we could take an average of the rolls. Over time, we saw that when you focus on the average of multiple die rolls, that the shape of the distribution becomes more normally shaped, like a bell-shaped curve. The average is the average you would expect in theory for rolling dice, which is 3.5, and the standard deviation got smaller as the sample got larger over time. This leads us to the version of the central limit theorem for means, which says that no matter what type of population distribution you start with, it can be any distribution, uniform like rolling dice or any other distribution, that when you start to focus on the mean of the values, you get a normal distribution that has a population mean of mu, the theoretical mean of the population, and the standard deviation is your standard deviation from the individual data points divided by the square root of n, which is the sample size. We can apply this formula just like we did with the proportions to solve a variety of different questions. So let me show you how these questions work. The first example we're going to look at is on dogs. So it is learned that the population of white German Shepherds in the US is 4,000 dogs, and the mean weight for German Shepherds is 75.45 pounds. It's also learned that the population standard deviation is 10.537 pounds. If a random sample of 225 dogs is selected, find the probability that the sample will have a mean that is 2 pounds or more than the population value. So the first step, just like we did for proportions, is to identify the values given in the question. So in this question, we're told that the population of all German Shepherds has an average or mean weight of 75.45 pounds. We're also told that in the sample, we want to find the probability that the sample will have a mean that is 2 pounds or more than the population valued. So we're saying is the sample mean this value, the population, or 2 pounds more. So it'd be 77.45 for the sample mean we're looking for, 2 pounds or more than the population value. We're also told that they take a random sample of 225 dogs, so that's our n value. We want to calculate the standard deviation. The standard deviation uses this formula, population standard deviation over square root of n. The population value is given in the question, 10.37. So the formula we would need to use is just to take that value and divide it by the square root of n, the sample size. Make sure you're using your cell references so that you don't lose any precision. And you should get a value of about 0.69. Just like for proportions, we should check our conditions to use the normal distribution and the central limit theorem. If the dogs are randomly selected so that they're not brothers or sisters or things like that, should one dog be independent of another? The answer should be yes. One dog should not impact another if they are randomly sampled. Then they're not owned by the same owners or anything like that. Does the question say their sample is random? If we review the question, it does say if the random sample size is 225 dogs. So the question states random sampling. For the 10% condition, they sample 225, but the question says there's 4,000 dogs that are that breed in the US. So 225 is less than 10% of 4,000 dogs of this breed in the USA, so that condition is met. And the sample size condition to check that the sample is not too small is a bit different for means than for proportions. For proportions, you have to check both NP and N1 minus P were greater than 5. But for the mean, all you have to make sure is that the sample size should be at least bigger than 40. If you have a sample size 40 or more, that's when you should always start getting that normal bell-shaped curve. Just like for rolling dice, we started to see the normal curve really appear for dice more than 3 or 4 rolls being taken. In general, as long as you have at least 40 as a sample size, the normal condition should hold. That was one of our conditions in the last lesson that we ended off with. So it is bigger than 40. So the normal condition should hold because we have 225 dogs in the sample. With all of these being met, that means we can use the normal distribution to find the probability. So with the normal distribution, we're trying to see if you get this sample mean with this population mean, and this is our standard deviation of the sampling distribution. We know that when you use the norm.dist function, it's always going to give you the less than probability. So of being 77.45 pounds or less. Does that match with what the question asks for? It says find the probability that the sample will have a mean that is 2 pounds or more than the population value. So if we want 2 pounds or more than the population value, I'll draw out a little picture so we can see what part of the distribution probability we're looking for. Oh, my tablet's just reconnecting. Here we go. So here's my distribution. We're told in the question that the mean is 75.45. All normal distributions are defined by a mean and standard deviation. So the standard deviation of the sampling distribution is 0.69133. That's technically sigma over root n. And what we want is the probability of getting a weight of 77.45. And the question says, mean that is 2 pounds or more than the population value. So that'd be this part here, 2 pounds or more. Whenever you have a greater than or more question, that's the scenario where we have to do a 1 minus from the norm dist, because norm dist by itself always gives the less than probability. So for the more than probability, you have to do 1 minus, and that will be my final answer. The next question is on battery life. The length of time a particular smartphone's battery lasts follows an exponential distribution with a mean of 10 months. A random sample of 64 of these smartphones is taken. So this question might look like it's missing a lot of information because really all it says is the mean life is 10 months, so that's the mean, and that the sample size is 64. It doesn't really give you any other information. But the reason why the question doesn't really need to give you much more information than that is because the question says the distribution is exponential. And for the exponential distribution, we have given formulas for the expected value and the variance. Back in Learning Outcome 4, when we learned about the different distributions, I provided a table for each of the distributions that summarized important information about the distribution, and we did have formulas for the expected value and the variance. If the mean, mu, is 10, then if you rearrange this formula to solve for lambda, which is our rate parameter, it would be 1 over the mu value. So lambda will be 1 over 10 or 0.10. Why we want to use that value is we would want to use it to solve for the variance using this formula. So the variance is 1 divided by the lambda value to the power of 2 or squared. So that would be the variance. We don't want the variance though, we want the standard deviation. The standard deviation is always the square root of the variance. So I would just add a square root to that number. And the standard deviation is actually also 10. So both the mean and standard deviation would be 10. But if we want the standard deviation of the sample mean, according to the central limit theorem, it always gets smaller. So we have to take the standard deviation and then divide by the square root of the sample size, just like we did for the previous question. And then we're done. So our standard deviation of the mean is 1.25. Now we'll have the values we need to solve for a probability. Before we solve for the probability, we should check our conditions to make sure that we can actually use the central limit theorem and the normal dist function in Excel to solve for the probability. So first, do you think that one person's smartphone impacts another if they're randomly selected? Again, no. If the cell phones are randomly selected, then they shouldn't impact each other. Does the question say there is a random sample? Yes, it says a random sample of 64. For the 10% condition, do you think 64 is less than 10% of all smartphones? Yes. For any company, whether talking about iPhone or Google or Samsung, they should have more than 640 phones produced in the population. So this condition will be met. And finally, the last one, make sure the sample is not too small. 64 is bigger than 40, so the normal condition will hold. So all of our conditions are met, which means we can use the norm.dist formulas. So if we first want a probability of getting between 7 and 11, this is a between question. So we'll have two different probabilities. So I'm going to use the norm.dist function twice, one with 7, the first value, our mean, and our standard deviation for the sample mean. Make sure you're using the second standard deviation and not the first. And I get about 0.008. Then to get my probability of getting 11 as a value, I'll put in my mean and standard deviation, the second standard deviation of the sample mean. And again, this will give me my probability of getting a score of 11. Finally, for all between probabilities, we'll take the difference between the two values, the bigger minus the smaller, and that gives me about 77, I would round up to 78% chance. If you want to draw out what this would look like on the normal curve, according to the central limit theorem, I've got my mean, I've got my standard deviation value. Then 7 would be below the mean score, and 11 is just above. To get the between probability, I'm within this range here. And it's close to a 78% chance of being within that range. I also added a question here. That's one of the opposite questions where you have to solve for an X value given a probability, where it asks you to find the 80th percentile for the total length of time the smartphone batteries will last. To do this, you need your probability. And then instead of using the norm.dist function, you would use norm.inv. Our probability is 80%. 80th percentile means 80% or less. So we can simply just use this function. You don't need the 1 minus. The mean is 10, and the standard deviation of the sampling distribution is the 1.25 value. So a score of about 11.05 corresponds to the 80th percentile of battery life. So that'd be the mean value for how many months the smartphone's battery will last. 11.05. Okay. So the last question we have here is about company employees that we'll look at for the mean. So a company has 800 employees. The average number of work days between absence for illness is 123 with a standard deviation of 14 days. A random sample of 50 employees is examined. What is the probability a sample has a mean of work days with no absence for illness of at least 124 days? So the number given in the question is that the average number is 123 days, but we want the probability for 124. So that's going to be the sample value. We're told there's a random sample of 50 employees. The standard deviation from the question is 14 days. To find the standard deviation of the sample, you have to take that value and divide it by the square root of the sample size. That will make the standard deviation of the mean smaller than the original standard deviation for all the data. Just like we said, it's in the last example, it's harder to get one unusual mean than it is to get an unusual individual value. And that's why the standard deviation gets smaller. To check our conditions for the central limit theorem, would one employee taking a sick day be independent of another? If there's 800 employees and we're randomly sampling only 50 and they're not people who like share the same desk and might be getting each other sick with their germs, then yes, they should be independent, but it is very important that they're selected randomly so that they're not desk mates, for example. If I take a sick day, it shouldn't impact if you do unless I got you sick, like I was saying. Does the question say it's a random sample? Yes. The question states the sample is random because we have to have random samples for the central limit theorem to hold. Would 50 be less than 10%? Yes, 50 is less than 10% of the 800 employees because 10% of 800 would be 80. So 50 is less than that. And for the sample size, 50 is greater than 40, so the normal condition will hold. Again, when we're talking about the mean, you just need to check it's bigger than 40. You don't need to check the NP and 1 minus p condition because that's only for proportions. And then finally, I can find this probability. The question asks for at least 124 days. So what that means is if I've got my roughly normal curve, 123 is the mean in the middle. At least 124 means that we want a sample of 124 or higher. That's what at least means. So if I'm, calculating that probability, I'm going to use my norm.dist function. My x value is the 124. My mean is the 123. My standard deviation is the one that I calculated. This will give me the less than probability. If you want the more than probability, you have to do 1 minus that value. And that gives me about 30% chance. And this is our final question for the means. If you have any questions about any of these calculations, please reach out and I'll be happy to assist you. There's one more video where I'll show you some questions I want you to try on your own, and then I'll show you the solution for the learning check questions. Thank you.